Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes, we're traveling to the universe next door, the graceful, spiraling Andromeda Galaxy. From its ancient beginnings to its quiet, star-filled neighborhoods, we'll explore 100 sleepy facts to help you relax, unwind, and drift peacefully through cosmic space. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes and let's begin. Fact 1. The first quiet swirl of Andromeda. Long before the galaxy we call Andromeda ever shimmered across the night, there was only a soft, formless cloud drifting through the early universe. It was a place without shape or sound, just a mist of hydrogen and helium gently folding into itself. Over countless millions of years, tiny ripples in this cosmic fog began to draw matter together, little by little, like dew gathering on a morning leaf. As more gas collected, a quiet swirl formed, so slow and delicate you could not have seen it, even if time itself paused. This faint rotation was the earliest heartbeat of Andromeda, a promise of stars and spirals yet to come. And in that stillness, the galaxy began its patient rise from nothingness and drifted onward toward the next stage of its becoming. Fact 2. A galaxy grown from ancient clouds. After its first gentle spin began, Andromeda continued to gather material from the space around it. Wisps of gas streamed inward like soft river currents, settling into the growing gravity at its center. With every passing epoch, more hydrogen arrived, drifting down like slow-falling snow, each grain a possible star waiting to ignite. In this deep, unhurried process, the galaxy expanded. Small clumps of matter merged peacefully, adding their mass to the growing structure. These early clouds were simple, quiet things, yet from them, the foundation of an entire galactic family was laid. The galaxy to be stretched wider, smoothing its edges, shaping itself around the silent pull of gravity. And far from noticing its own transformation, it continued gathering, preparing for the first sparks of starlight that would one day shine across the universe. Beyond this era of mist and memory, the first true stars were about to flicker awake. Fact 3. The slow gathering of primordial stars. When Andromeda was still young, its first stars formed like gentle embers, glowing in a vast, dark hearth. Gravity pressed the densest pockets of hydrogen together until they warmed, brightened, and finally burst into light. These early stars, massive, brilliant, and short-lived, shone with a blue-white intensity that illuminated the quiet galaxy in the making. They lived fast, burning through their fuel in only a few million years, but their light washed through the surrounding clouds, shaping and stirring them. Even as these giants faded, their ashes enriched the galaxy, seeding it with heavier elements for new stars to come. And so, in this calm, ancient dawn, Andromeda began to sparkle. One soft point of light at a time. Beyond those early flickers, the galaxy was preparing for whole streams of stars yet to form. Fact 4. Streams of hydrogen becoming a home. As Andromeda continued to settle into its newborn shape, rivers of hydrogen flowed inward from every direction. These currents were gentle, almost ghost-like, stretching across space in long, pale threads. Each stream added new material to the growing disk, feeding it the way quiet rain nourishes a field. Over time, these drifting particles pooled into dense pockets, preparing the galaxy for waves of star formation still to come. The young Andromeda was not yet the grand spiral we know today. It was still a loose, hazy structure, more suggestion than form, but it had begun gathering the ingredients of a cosmic home. With every passing million years, these streams shaped its future gently, patiently, and without hurry. And in that slow assembly, the galaxy breathed deeper, awaiting the darker forces that would guide its growth. Fact 5. How dark matter shaped the silence. Hidden behind the soft glow of stars and gas, something unseen held Andromeda together. A halo of dark matter, quiet, invisible, yet immensely powerful, formed a vast cocoon around the galaxy. It didn't shine or warm or glow, but its gravity shaped everything, pulling the early clouds into place and guiding the first fragile rotations. Without this silent scaffold, Andromeda's stars would have drifted apart like fireflies in a breeze. Instead, dark matter gently cradled them, holding the galaxy's developing form with a steady, unseen hand. It created a deep well of gravity, allowing the swirling disk to expand in balance and harmony. Even now, billions of years later, this mysterious halo remains. We can't see it, but the galaxy's motion whispers its presence. And with dark matter's quiet support, Andromeda's core began to strengthen. Fact 6. The early heartbeat of a galactic core. At the center of the young Andromeda, a dense cluster of stars slowly took shape. They formed a bright, compact region, a growing heart, where the galaxy's earliest activity settled. This core rotated more quickly than the outer clouds, its motion smooth and rhythmic, like the gentle pulse of a creature just beginning to wake. The stars here were born close together, sharing heat, light, and gravitational pull. Their orbits wove a tapestry of motion, creating the calm but steady heartbeat that would anchor the galaxy for the rest of its life. Over time, this core pulled in more material, guiding the development of Andromeda's central shape. In the quiet glow of this concentrated light, the galaxy found its center. And beyond that center, a great disk of stars was about to unfurl. Fact 7. A disk born from cosmic drift. As Andromeda matured, its swirling clouds began to flatten into a broad, graceful disk. This was not a sudden change, but a slow settling, like dust drifting down through still air. Each particle followed the soft pull of gravity and rotation, gradually arranging itself into a thin, sweeping plane. Within this forming disk, the first organized patterns of stars began to appear, hints of the spiral shape that would one day stretch across the sky. The young galaxy continued collecting stray material from its surroundings, feeding and smoothing the disk over millions of years. With every gentle rotation, its structure became clearer, wider, and more serene. And from this settling shape, the early promise of spiral arms began to whisper into being. Fact 8. The first rotation, gentle and new. Once the disk took form, Andromeda began its first true rotation. A motion so slow and vast that it couldn't be felt, only witnessed across deep time. It turned like a quiet wheel in space, carrying its stars along paths that wrapped around the core. Each orbit was measured not in years, but in millions of years. So long that a single rotation marked the passing of eras. This steady spinning helped balance the galaxy, preventing the inner regions from collapsing inward while guiding the outer clouds into harmonious motion. Over time, the rotation smoothed the disk, sharpening its shape and giving it the stability of a mature spiral. And as the galaxy completed these slow, majestic turns, it prepared to gather the faint halo that would surround it. Fact 9. The halo that formed before the light. Surrounding the developing disk, a vast diffuse halo of ancient stars and unseen matter stretched outward into the dark. Many of these stars were among the oldest in the galaxy, remnants from Andromeda's earliest days, long before the spiral arms formed. They drifted in wide, quiet orbits, scattered like faint lanterns along the edge of a forest clearing. The halo moved differently from the disk beneath it, slower, more irregular, carrying the memory of the galaxy's primal beginnings. Within this immense sphere of influence, dark matter provided the framework, anchoring each wandering star with gentle gravitational pull. Though often overlooked, the halo carried the galaxy's first whispers of structure, a silent outline waiting for the brighter stars to fill it in. And from that faint boundary, Andromeda's first clusters began to gather. Fact 10. A quiet sea of star clusters. Before Andromeda became the majestic spiral we see today, it was adorned with countless compact star clusters. These clusters floated within and around the forming halo, like tiny islands scattered across a calm ocean. Each one held hundreds of thousands of stars, packed tightly together, their combined glow giving the early galaxy a soft, speckled shimmer. These clusters were some of the first organized structures in Andromeda, forming before the grand disk fully settled into place. They marked regions where gravity had gently gathered matter into dense, luminous knots, preserving some of the oldest stars the galaxy would ever know. Even now, these ancient clusters drift quietly around Andromeda, keeping watch over the galaxy they helped shape. And from their scattered light, Andromeda's clearer spiral form began to take shape. Fact 11. The classic spiral. With a soft glow, over billions of years, Andromeda unfurled into a grand spiral galaxy, its arms stretching out like gentle currents of starlight. From afar, the entire structure looks serene, a glowing pinwheel drifting through the darkness. The spiral arms wound gracefully around the core, each curve holding clusters, nebulae, and stars in delicate patterns shaped by rotation and gravity. Though this spiral design appears solid and distinct, it is actually made of countless stars moving independently, tracing a pattern that only seems like a continuous ribbon. Their collective glow creates the soft, hazy brightness we see from our place in the Milky Way. This familiar spiral shape is one of the reasons Andromeda feels like a mirror of our own home. And beyond these gentle arms lies a vast realm of calm cosmic space. Fact 12. 2 million light-years of calm. Despite its size and brilliance, Andromeda lives peacefully far from us, across an immense gulf of darkness. Its light travels more than 2 million years before reaching Earth, a journey so long that the stars we see now have shifted quietly in the time it has taken their glow to arrive. That distance creates a soft sense of stillness, as though we are watching the galaxy through a window of deep time. From our perspective, Andromeda appears faint and gentle, a blur to the naked eye, yet vast beyond imagination. This space between us is filled with nothing but thin dust, scattered atoms, and quiet darkness. A serene cosmic corridor linking two spiral galaxies. And along this peaceful bridge, Andromeda's sweeping arms extend even farther into the night. Fact 13. The wide sweeping galactic arms. Andromeda's spiral arms are vast, elegant structures that wind softly around its glowing center, They are not solid pathways, but gentle regions where stars gather, drift, and slowly disperse over time. These arms hold countless suns, nebulae, and clusters, each moving in its own rhythm, yet together, forming a pattern as quiet as a watercolor swirl in space. The arms stretch for tens of thousands of light years, curving outward with a patience that only galaxies possess. From afar, they shimmer like silver threads laid across velvet. Their shape is guided by rotation, density, and the subtle pull of gravity, creating the illusion of a steady, flowing wave. And beyond these sweeping curves, deeper structures hide quietly within the light. Fact 14. A bar-shaped core hiding in plain sight. At the heart of Andromeda lies a bar-shaped structure made of stars, a slender, glowing bridge that spans the central region. To the eye, it blends into the core's brightness, almost invisible unless you look with careful, infrared-sensitive instruments. But within this quiet bar, stars move along elongated orbits, flowing in smooth, synchronized paths. This bar helps channel gas toward the galaxy's center, guiding material inwards like a slow-moving tide. It shapes the inner structure of Andromeda, influencing how stars form and how the galaxy rotates. Though subtle, this bar is a key part of Andromeda's graceful design, a hidden framework beneath the broader spiral. And just outside this bright center, the galaxy bends in ways both gentle and surprising. Fact 15. The warp in Andromeda's outer disk. Far from the bright, orderly spiral arms, Andromeda's outer disk bends slightly, creating a soft warp that curls upward on one edge and downward on the other. This distortion is delicate, a faint ripple in the galaxy's wide, starry sheet, but it reveals much about Andromeda's past. The warp likely formed from interactions with smaller galaxies, their gravity tugging ever so gently at Andromeda's edges over billions of years. These subtle pulls bent the disk, giving it a gentle twist that still persists today. From certain angles, the warp makes the galaxy seem like a slowly turning leaf, curved by ancient winds. And beyond this rippled edge, even fainter rings of stars begin to appear. Fact 16. Gentle rings. Within the spiral deep within Andromeda's spiral structure lie faint, delicate rings, subtle loops of stars and dust that circle the galaxy like ripples on a quiet pond. These rings aren't perfect or rigid. Instead, they drift softly, shaped by past interactions and the galaxy's own patient rotation. Some rings glow with young, blue stars, while others are dusky and muted, carrying the warm tones of older suns. Astronomers believe these rings may have been sculpted by ancient encounters with nearby galaxies, each passing touch leaving behind a circular echo. Seen in infrared light, the rings appear like soft halos, layered gently within the greater spiral. And just beyond these inner ripples, the galaxy's outskirts stretch into the faintest reaches of its radiant disk. Fact 17. The faint, feathered edges of the halo. At the farthest boundary of Andromeda, the galaxy blends gradually into a vast halo, a broad whisper-light sphere of scattered stars. These stars are old, fragile remnants from the earliest times, drifting through space like dim embers floating at the edge of a long, quiet fire. They trace wide, slow orbits far above the spiral arms, moving almost imperceptibly through the darkness. The halo isn't uniform or dense. Instead, it's gentle and feathered, fading slowly into the surrounding void. Within it lie the traces of ancient galactic mergers, long ago collisions whose stars were stretched and thinned until only faint trails remain. These ghostly strands linger like memories, offering quiet clues about Andromeda's deep past. And wrapped inside this soft halo is a galaxy far larger than our own. Fact 18. A galaxy, twice the size of our own. Though it appears as a small blur from Earth, Andromeda is immense, nearly twice the diameter of the Milky Way. Its starry disk stretches more than 220,000 light-years across, a grand, sweeping structure that would dwarf our home if placed beside it. This size comes not only from its luminous regions, but also from its extended halo, which spread even farther into the dark. Because of its vastness, Andromeda holds more stars, more clusters, and more drifting streams than our galaxy. Yet despite this scale, it moves gracefully, rotating with a slow, steady rhythm that shapes its spiral arms. And just beyond this enormous form lies a subtle connection, a quiet bridge of matter, linking Andromeda to its cosmic neighbor. Fact 19. The bridge between two cosmic islands, stretching across the darkness between Andromeda and the Milky Way, is a faint, delicate stream of gas, known as the intergalactic bridge. It's not bright or solid, more like a soft whisper of hydrogen drifting quietly between two great spirals. Though incredibly thin, this bridge hints at a long history of gravitational connection, a silent pull that has linked the galaxies for ages. Over time, tiny particles and stray stars have moved along this tenuous path, carried by the gentle tides of gravity. To us, it seems impossibly subtle, hidden beneath the vast distances that separate our worlds. But its presence reminds astronomers that galaxies are not isolated. They feel each other's influence across millions of light years. And as this bridge stretches onward, the stars within Andromeda shine by the trillions. Fact 20. The soft gradient of stars. Within Andromeda, stars gradually change as you move from the bright core outward to the dim edges. Near the center, the stars are older, warmer toned, and densely packed, creating a soft golden glow. As you travel outward along the spiral arms, the stars become younger and bluer, sprinkled more loosely across the dark like scattered sparks. Farther still, the outer regions fade into a gentle wash of cooler, dimmer stars, each one drifting slowly in wide orbits. This transition isn't sharp, but smooth and gradual, like the fading colors of a sunset. The change in stellar populations reveals the galaxy's long history, where stars once formed quickly and where they now remain quiet and calm. And beyond that gradient, the youngest, brightest stars cluster in vivid blue groups. Fact 21. A trillion stars in the dark Andromeda is home to an astonishing number of stars, roughly 1 trillion, each glowing quietly in the vastness of space. Some are small, steady red dwarfs that will burn softly for trillions of years. Others are massive blue giants that shine fiercely for short lives, illuminating the spiral arms with their radiant light. Between them lie countless suns like our own, each with its own story, its own orbit, its own gentle place within the galaxy. Despite their number, these stars do not crowd or collide. They glide past each other in peaceful paths, separated by immense stretches of darkness. Together, they create the soft, hazy glow we see from millions of light years away. And among this trillion-fold brightness, new stars begin their journeys in calm, clustered nurseries. Fact 22. The bright giants of the spiral arms. Scattered along Andromeda's sweeping spiral arms are vast, luminous giant stars, enormous blue suns that shine with a brilliance thousands of times greater than our own. They gather in loose clusters, illuminating the surrounding dust, with a cool, radiant glow. These giants are young in cosmic terms, born from dense clouds of hydrogen stirred by the gentle compression of the spiral arms themselves. Their powerful light travels across the galaxy, shaping the gas around them and carving out hollow regions where new stars will someday form. Though they burn quickly and fiercely, their presence gives Andromeda its vibrant highlights, the glowing knots of brightness that sparkle through telescopes. And beyond these glowing titans, cooler, calmer stars drift through quieter regions of the galaxy. Fact 23. Blue suns born in clusters. Many of Andromeda's brightest stars begin life in clusters, cozy cradles of gas and dust, where dozens or even hundreds of stars ignite within the same ancient cloud. These clusters are warm, lively pockets within the spiral arms, where gravity gathers material tightly enough for new suns to form almost side by side. Among them, the blue stars stand out with their shimmering icy light. They are enormous, energetic, and short-lived, glowing fiercely as they consume their fuel at astonishing rates. For a brief moment in cosmic time, these clusters appear like glittering jewels, suspended in the dark lanes of the galaxy. As the stars mature, their shared birthplace slowly disperses, leaving each sun to drift gently along its orbit. And beyond these youthful clusters, older stars keep quiet watch over the halo. Fact 24. Red giants, warming the halo. Far from the bright, active spiral arms, Andromeda's halo is home to countless red giant stars, aging suns that have swelled into vast warm spheres of glowing gas. Their light is softer and deeper than that of younger stars, casting a gentle reddish hue across the outer regions of the galaxy. These giants have expanded late in life, their outer layers drifting gently outward like a slow, cosmic exhale. Many of these stars formed billions of years ago, long before Andromeda took on its present shape. Their dim, steady glow carries the memory of the galaxy's earliest generations, whispering stories of ancient clusters and long-vanished companions. And from the halo inward, ever more varied stars fill the galaxy with quiet light. Fact 25. The quiet lives of yellow stars. Among Andromeda's trillion suns are gentle yellow stars, cousins to our own sun. These stars live calm, steady lives, burning their fuel slowly and evenly over billions of years. They shine with a warm, golden light, not too hot, not too dim, creating some of the most stable environments in the galaxy. Many orbit peacefully within the spiral arms, drifting without rush through lanes of dust and mist. These yellow stars rarely flare dramatically or change abruptly. Instead, they glow with a comforting consistency, their radiance like a quiet lantern in the night. Their long lifespans give any surrounding worlds ample time to form, evolve, and settle into their own calm rhythms. And among these steady suns, even older stars continue their patient glow deep in the galaxy's heart. Fact 26. The oldest stars still glowing. Andromeda contains stars so ancient that they began shining not long after the universe itself was born. These ancient suns are found mostly in the galaxy's halo and globular clusters, places where time seems to run slower and quieter. Their light is faint and soft, worn down by billions of years of gentle burning, yet still steady against the darkness. These stars formed from the universe's earliest ingredients, mostly hydrogen, with very few heavier elements. Because of this, they hold clues to the conditions of the young cosmos, long before galaxies had fully taken shape. Their orbits are wide and slow, drifting through the halo like quiet wanderers who have watched ages come and go. And even older memories lie hidden in the dusty clouds where new stars wait to form. Fact 27. Stellar nurseries, hidden in dust. Deep within Andromeda's spiral arms lie dark, velvety clouds of dust where new stars are quietly born. These stellar nurseries are cool and thick, shielding young stars from view until they grow bright enough to pierce the surrounding mist. Inside, gravity pulls the gas together into dense knots, where the first warm glow of a newborn star slowly begins to rise. To the eye, these clouds look like shadows, soft, intricate shapes weaving through the bright lanes of the galaxy. But within them, entire clusters are forming, each star beginning its gentle life in the protective cradle of dust. Over time, winds from massive young stars will blow these nurseries apart, revealing the light within. And beyond those dark clouds, the galaxy pulses with stars whose brightness changes like a slow cosmic heartbeat. Fact 28. The calm pulse of variable stars. Scattered throughout Andromeda are variable stars, suns that gently brighten and dim in regular rhythms, like slow cosmic heartbeats. Some change subtly over days, while others shift in graceful cycles lasting weeks or months. These variations aren't chaotic or alarming. They're steady, predictable pulses caused by the star's outer layers expanding and contracting in a soft, breathing motion. For astronomers, these stars act as quiet beacons. Their reliable rhythms help measure distance across the galaxy, letting us trace Andromeda's vast shape with remarkable precision. But to the drifting clouds and neighboring stars, these gentle pulses are simply part of the galaxy's natural music, a soft flickering woven into the night. And as these rhythmic lights glow on and off, other stars near the end of their journeys fill the galaxy with quieter mysteries. Fact 29. The lives of dying suns. Even in a galaxy as serene as Andromeda, stars eventually reach the ends of their long, luminous lives. When smaller stars begin to fade, they shed their outer layers slowly, releasing delicate shells of gas that drift outward like expanding rings of color. At the center, a tiny white star remains, a faint, glowing ember that will cool peacefully over trillions of years. Larger stars end differently, collapsing into dense remnants or fading into darkness after casting off their final breaths of starlight. Though their endings sound dramatic, in the vast calm of Andromeda, even these transformations unfold gently across millions of years. These dying suns enrich the galaxy, scattering elements that future generations of stars can use to grow. And sometimes, a star ends in a moment of brilliant silence that leaves a lasting mark on the galaxy. Fact 30. Supernovae that once lit the dark. Across Andromeda's long history, massive stars have occasionally ended in supernovae, bright, powerful bursts of light that for a brief time outshone entire star clusters. These events illuminated the galaxy like cosmic beacons, sending waves of energy and enriched material rushing into the surrounding clouds. Though their brilliance was fleeting, their impact lasted far longer, stirring gas, triggering new star formation, and carving gentle cavities in the galactic arms. Supernovae are rare on human timescales, occurring perhaps once every few centuries within a galaxy like Andromeda. Yet each one leaves behind a quiet remnant, a faint nebula, a dense core, or simply starlight encoded with heavy elements. And beyond those ancient flashes, new clouds are always forming, preparing for the next generation of stars. Fact 31. Clouds that cradle. New light, Within Andromeda, vast clouds of gas and dust drift like soft shadowed blankets across the spiral arms. These clouds are the quiet cradles of newborn stars, places where darkness isn't emptiness, but possibility. Inside their cool interiors, tiny grains and drifting atoms slowly gather, nudged together by gravity until the first warmth of fusion begins deep within their hidden cores. These early star seeds glow faintly at first, wrapped in layers of dust that keep their light from escaping. Only when they grow strong enough to shine through their surroundings do they reveal themselves, illuminating the cloud from within like lanterns in a fog. Entire clusters can form this way, dozens of stars sharing the same dark beginnings. And nestled within these dusky realms, one region in particular stands out as a stellar giant. Fact 32. The Giant Star Factory, NGC 206. One of Andromeda's brightest treasures is NGC 206, a vast star-forming region filled with young, luminous blue stars. It's a bustling nursery on a galactic scale, stretching hundreds of light years across. A place where new suns shine fiercely, lighting up the surrounding dust like a miniature sunrise. These stars are among the most massive and energetic in the galaxy, born from an unusually dense cloud that collapsed long ago. NGC 206 glows with vibrant intensity because its stars are still young, hot, and full of brilliant energy. Their combined radiance sweeps outward, shaping the nearby gas into gentle waves and filaments. For astronomers, this region is a glimpse into the galaxy's most active moments of creation. And as these bright stars continue to grow, quieter pockets of light shimmer gently across the surrounding arms. Fact 33. Quiet pockets of emission. Nebulae, scattered throughout Andromeda, are small, glowing nebulae, delicate regions of gas that shine softly when touched by the light of nearby young stars. These emission nebulae appear as gentle, rosy clouds, their colors created as starlight energizes the hydrogen within them. Though they may seem faint and fragile, they mark places where star formation has recently stirred the darkness. Inside these nebulae, warm gases swirl in intricate shapes, drifting like ribbons of pastel smoke. They illuminate the spiral arms with subtle highlights, tracing the paths where stars have recently emerged from their dusty cradles. Each glowing pocket is a quiet reminder of the galaxy's ongoing cycle of birth and renewal. And beyond these luminous clouds, dark lanes of dust weave softly through the arms, shaping the galaxy's quiet patterns. Fact 34. Dust lanes, flowing like smoke. Threaded through Andromeda's bright spiral arms are long shadowed dust lanes, drifting like soft trails of smoke across the galaxy's glow. These dark rivers of interstellar dust absorb starlight, creating gentle contrasts that outline the spiral structure with quiet elegance. They appear as cool, velvety streaks, weaving through the luminous arms like ink and water. Inside these lanes, the dust grains are small and ancient, tiny fragments of carbon and silicate left behind by dying stars. Though they may dim the light, they also nurture creation, offering the perfect conditions for new stars to slowly take shape. Without these dark paths, Andromeda's arms would lose much of their depth and mystery, and as these dust lanes drift onward, cooler regions form where hydrogen waits in patient stillness. Fact 35. Cool hydrogen, waiting to ignite. Across Andromeda, immense clouds of cool hydrogen linger in the quiet spaces between bright star clusters. These clouds are vast reservoirs of potential, holding the raw material for future stars. For now, they remain chilled and tranquil, drifting softly through the spiral arms like gentle, unseen tides. Within them, atoms move slowly, waiting for the right moment when gravity begins its subtle gathering. As the clouds are compressed, perhaps by passing waves in the spiral arms or gentle pressure from nearby giants, their densest regions warm and condense. This is the first step toward starbirth, a patient process that can take millions of years. Until then, the hydrogen rests, offering no hurry, no urgency, just calm, drifting possibility. And on the edges of these quiet clouds, faint structures begin to stretch like threads of cosmic silk. Fact 36. Turbulent clouds, slowed by time. Some of Andromeda's gas clouds are stirred by gentle turbulence, slow, swirling motions created by nearby stars, ancient supernovae, and the galaxy's steady rotation. These motions wrinkle the clouds into intricate shapes, full of folds and filaments that shift across thousands of years. Though called turbulent, the movement is soft and graceful, more like drifting mist caught in a slow breeze than anything chaotic. Over time, this motion allows pockets of gas to gather and thicken, creating the seeds of future stars. But because everything unfolds on such vast timescales, even the most active regions feel peaceful when seen from afar. Each swirl, each eddy, is part of a long, unhurried dance that has shaped the galaxy for billions of years. And deep within these drifting clouds, faint filaments glow where starlight touches them with gentle warmth. Fact 37. Soft filaments of starlight. In the quieter regions of Andromeda's spiral arms, delicate filaments of glowing gas stretch like threads of soft light. These wispy structures are shaped by the gentle push of stellar winds, faint breezes from young, energetic stars that carve narrow channels through nearby clouds. Each filament glows with a pale radiance, illuminated by the stars that created it, forming intricate patterns almost too faint to see. From a distance, these filaments resemble fine brushstrokes across a vast cosmic canvas. They drift slowly, shifting their shapes over thousands of years, never rushing, never settling into rigid lines. Their glow marks the subtle interactions between starlight and gas, the tender touches that sculpt the galaxy's luminous face. And beyond these glowing threads lie regions warmed not by visible light, but by the gentle heat of infrared waves. Fact 38. The warm glow of infrared regions. While much of Andromeda shines with visible starlight, some of its most peaceful beauty appears only in infrared, a warm, gentle glow that reveals hidden clouds, quiet dust, and the soft warmth of recently formed stars. In these wavelengths, the galaxy looks calmer still, illuminated not by brilliant bursts, but by the slow release of heat from dust grains warmed by nearby suns. Infrared light drifts through the dust that blocks visible wavelengths, unveiling structures that would otherwise remain unseen. Entire networks of star-forming regions become clear, delicate arcs, faint knots, and smooth, glowing patches that show how the galaxy breathes and evolves. It is a softer portrait of Andromeda, one that highlights warmth instead of brightness. And as this gentle heat radiates outward, the fading remains of ancient births linger quietly in the background. Fact 39. Quiet remnants of ancient births. Throughout Andromeda, the remnants of long-ago star formation are scattered like soft memories. These remnants may be faint shells of gas, thin arcs left behind by stars that once shone fiercely before drifting into calmer stages of life. Others are subtle clearings in the dust, places where past generations of young stars pushed away the surrounding material, leaving soft-edged bubbles in their wake. Though these remnants no longer blaze with youthful intensity, they still carry the imprint of what once was. Their shapes are gentle and eroded, smoothed by millions of years of cosmic weathering. Each whisper of gas, each faded cavity, is a reminder of the galaxy's continuous cycle of creation and transformation. And beyond these ancient echoes, the very rhythm of the galaxy pulsates in calm, steady stages. Fact 40. A galaxy breathing in stages. Andromeda doesn't form stars at a constant pace. Instead, it moves through slow, gentle cycles, quiet periods where gas drifts and gathers, followed by more active eras when new stars ignite in bright clusters. These breaths unfold over hundreds of millions of years, a rhythm far too vast for human senses, yet deeply woven into the galaxy's history. During the calm phases, gas settles, cools, and waits like a still lake before dawn. In the active phases, waves of starlight ripple outward as fresh clusters illuminate the spiral arms. These cycles give Andromeda its layered structure, with young regions sitting beside older, quieter neighborhoods. And while the galaxy breathes, smaller companions circle around it, sharing its long journey through space. Fact 41. The loyal companions, M32 and M110. Two dwarf galaxies travel alongside Andromeda like gentle attendants, M32 and M110. They are much smaller and quieter than their giant neighbor, but each carries its own distinct charm. M32 is compact and bright, appearing like a soft, condensed glow beside Andromeda's broad disk. M110, slightly larger and more diffuse, looks like a faint smudge of starlight drifting below the main galaxy. These companions orbit Andromeda slowly, influenced by its immense gravity. Over billions of years, they have likely contributed stars to Andromeda's halo, their outer layers gently pulled away in soft streams. Yet despite these exchanges, they remain loyal satellites, accompanying the galaxy across cosmic time. And beyond these two bright companions, an even larger family of small galaxies follows in quiet formation. Fact 42. A swirling family of dwarf galaxies. Andromeda is surrounded by a flock of dwarf galaxies, small, faint systems bound together by gravity, each moving along its own slow orbit. Some are spherical, like dim lanterns hanging in the darkness. Others are irregular, shaped by ancient tidal encounters that left them stretched and softened at the edges. Together, these dwarfs form a vast, intricate dance around Andromeda. Many of these small galaxies contain only a few million stars, yet their histories are rich. Some were once more massive before Andromeda's gravity gently stripped them down, leaving behind quiet cores. Others drift serenely, untouched, following long, looping paths through the halo. And among these circling dwarfs, the remains of vanished galaxies still linger, like faint trails in the dark. Fact 43. The ghostly remnants of cannibalized galaxies. Throughout its long history, Andromeda has gently absorbed smaller galaxies, pulling them into its halo and blending their stars with its own. The remnants of these ancient encounters drift like faint ghosts. Long, fragile streams of stars stretched across the outskirts of the galaxy. Some are so thin and diffuse that they almost disappear into the dark, visible only through careful observation. These stellar remnants carry the memories of galaxies that once wandered too close, their shapes softened and dissolved by Andromeda's tidal pull. Though they no longer exist as separate systems, their stars continue orbiting peacefully, whispering quiet stories of past mergers and cosmic change. And woven among these ghostly trails are even more intricate streams shaped by gravity's patient hands. Fact 44. the tidal streams, curling around Andromeda. Encircling. Andromeda are graceful tidal streams, long curving ribbons of stars that loop through the galaxy's halo, like threads caught in a slow breeze. These streams form when smaller galaxies pass close enough for Andromeda's gravity to gently stretch them apart, pulling stars into looping arcs that wrap around the larger galaxy. Some streams are broad and smooth, while others appear thin and delicate, tracing paths that span tens of thousands of light years. From afar, they resemble the trails of comets, but on a scale so immense that a single loop can take a star billions of years to complete. Each stream is a quiet reminder that galaxies are constantly shaping one another, even through the most subtle of encounters. And within these looping paths, many stars reveal origins far different from those born within Andromeda itself. Fact 45. Halo stars, from long-lost neighbors. Among the stars that shimmer softly in Andromeda's vast halo, many did not originate within the galaxy at all. They were born in smaller companions long since absorbed, stripped, or faded into the surrounding darkness. These stars now orbit alongside Andromeda's own, their histories woven into the larger galaxy's outer layers. Halo stars often travel in wide, tilted orbits that differ from the steady rotation of the disk. Their paths trace the memories of the galaxies they once belonged to, preserving ancient motions that have survived countless ages. Because they are old and faint, they form a quiet, mysterious population, a sprawling archive of Andromeda's past interactions. And as these adopted stars drift through the halo, the rhythmic dance of the satellite galaxies continues in calm, unhurried orbits. Fact 46. The slow dance of satellite orbits. The dwarf galaxies that surround Andromeda follow long, looping orbits that take billions of years to complete. Their paths are not perfect circles, but gentle ellipses, stretching far into the halo before curving back toward the central glow. To us, their movement is imperceptibly slow, a quiet dance playing out across cosmic ages. Some satellites move in loosely aligned planes, as though sharing a subtle choreography shaped by ancient gravitational tides. Others wander individually, tracing solitary arcs through space. Their orbits are reminders that galaxies are not static islands. They carry companions with them, each one moving to its own tranquil rhythm. And while these dwarfs drift in their patient paths, many hide a deep secret within their faint, fragile forms. Fact 47. Dwarfs, rich in dark matter. Though dwarf galaxies look soft and delicate, they are built upon deep wells of dark matter, far more than their small size might suggest. This invisible mass acts like an unseen foundation, holding the galaxy together and preventing its stars from drifting apart. Without dark matter's silent gravity, many of these dwarfs would simply dissolve into space. In some cases, the dark matter outweighs the visible stars by hundreds or even thousands of times. This makes the dwarfs faint and ghost-like, with stars spread thinly across a deep, hidden core. Their presence helps astronomers trace the structure of dark matter around Andromeda, revealing the invisible web that binds the galaxy's extended family. And as these quiet companions orbit, Andromeda's gravity gently reshapes them over time. Fact 48. Galaxies, reshaped by Andromeda's pull. When smaller galaxies pass close to Andromeda, they feel its immense gravitational pull tug at their stars. This stretching is slow and graceful, happening over millions of years, a soft distortion rather than a violent tear. Shapes that were once round become elongated, and stars drift outward into gentle tidal tails, gradually blending with the halo. Some dwarfs lose only a little of their outer material, while others are slowly dismantled, their stars absorbed into Andromeda's growing outskirts. These interactions are part of the natural life cycle of galaxies, quiet exchanges of matter shaped by gravity alone. And as these reshaped galaxies continue their drifting orbits, long, faint streams of their stars remain as delicate reminders of encounters long past. Fact 49. A tangle of stellar streams. Around Andromeda, dozens of stellar streams weave through the halo like soft, wandering ribbons. Each one is made of stars gently pulled from smaller galaxies over billions of years, stretched into long strands that drift quietly through space. From afar, these streams form a delicate tangle, overlapping arcs, faint loops, and diffuse patches that reveal the intricate tapestry of Andromeda's past. Some streams are thick enough to stand out like pale brushstrokes across the dark, while others are so thin that only sensitive instruments can trace their paths. Together, they show how Andromeda grows not through sudden upheaval, but through slow, graceful mergers that unfold on timescales longer than we can imagine. And as these starry threads drift onward, deep in the galaxy's heart rests an invisible giant shaping everything around it. Fact 50. The sculpting hand of gravity. Gravity is the soft, steady artist that shapes Andromeda's grand structure. Though silent and unseen, it guides every star, cluster, and stream into its long, patient orbit. It pulls gently on the galaxy's companions, shapes the curve of the spiral arms, and determines the slow movement of gas clouds drifting across the disk. Every motion within Andromeda, no matter how subtle, is tied to gravity's quiet pull. This force does its work without rush. Stars may take hundreds of millions of years to complete a single orbit, yet gravity keeps them on their paths with unwavering steadiness. It is the cosmic thread that ties the galaxy together, creating an elegant arrangement of light and shadow that changes only in the softest ways. And near the very center of this vast gravitational sculpture sits a dark and powerful presence. Fact 51. A gentle giant in the dark. At the heart of Andromeda lies a supermassive black hole, a silent, shadowed giant millions of times more massive than our sun. Despite its immense strength, it does not roar or blaze. Instead, it rests quietly, shaping the motion of nearby stars with its deep, invisible gravity. The stars closest to it orbit at remarkable speeds, tracing tight curves around a center no light can escape. This black hole rarely feeds in dramatic bursts. It tends to draw in material softly, in thin streams of gas that warm and glow before disappearing beyond its boundary. From afar, it appears simply as a calm, dark anchor holding the galaxy's core in place. And surrounding this gentle giant is a dense cluster of stars that keeps it company in the quiet heart of Andromeda. Fact 52. The star cluster that guards it. Encircling Andromeda's central black hole is a dense, shimmering cluster of stars, a brilliant, tightly packed neighborhood glowing around the quiet darkness at the core. These stars move quickly, tracing swift, looping paths that reveal the presence of the hidden giant they orbit. Yet despite their speed, the cluster itself feels serene, a bright crown resting gently around the galaxy's heart. Many of these stars are old, their light softened by time. Others are younger, having formed from gas drawn inward by the black hole's subtle gravity. Together, they create a luminous cocoon that both surrounds and conceals the dark center, allowing the core to shine with modest beauty rather than fierce intensity. And by watching the stars of this cluster, astronomers learn how the unseen heart of Andromeda quietly shapes its surroundings. Fact 53. Evidence written in stellar motion. The clearest sign of Andromeda's central black hole comes not from light, but from motion. Stars near the core orbit at astonishing speeds, curving sharply around an empty-looking point that gives off no glow of its own. Their paths are like delicate signatures, tracing invisible loops that reveal the presence of an object too dense and dark to be anything but a black hole. By measuring how fast these stars move, astronomers can estimate the black hole's mass. Millions of suns packed into a space smaller than a single star cluster. These stellar motions act as quiet messengers, whispering secrets about the galaxy's hidden heart through their graceful, gravitational dance. And beyond the black hole's immediate influence lies another mystery. A central mass smaller than our galaxies, yet filled with ancient memory. Fact 54. A black hole smaller than ours. Andromeda's central black hole, though massive by any human measure, is actually smaller than the one at the heart of our Milky Way. While our own Sagittarius A car contains about 4 million solar masses, Andromeda's holds slightly less. A curious contrast, given that Andromeda is the larger of the two galaxies. This gentle imbalance hints at differences in their histories, shaped by past mergers, star formation, and the quiet flow of gas toward their cores. Despite being smaller, Andromeda's black hole plays the same patient role, anchoring the galaxy's center, guiding orbits, and influencing the structure of the surrounding bulge. It sits calmly within its starry nest, exerting its presence not through brightness, but through gravity alone. And around this calm center, quiet streams of gas drift inward, feeding the black hole in the softest of ways. Fact 55. How it quietly feeds. The black hole at Andromeda's center does not feast with fury. Instead, it feeds softly, drawing in thin, whisper-like streams of gas that spiral inward over long stretches of time. As this material approaches the event horizon, it warms and glows, faintly, creating a soft, diffuse halo rather than a bright, blazing frenzy. Most days, the black hole rests in near silence, content with only the smallest trickle of nourishment. This gentle feeding means the core of Andromeda remains calm and steady, untouched by the violent outbursts seen in more active galaxies. The surrounding stars continue their orbits unhurried, their paths undisturbed by sudden flares or scorching winds. And as this quiet giant rests, the heart of the galaxy remembers echoes from much older events. Fact 56. The calm heart of an ancient galaxy. Deep within Andromeda's core lies a sense of ancient stillness, a calm built over billions of years as stars formed, drifted, and faded within the central bulge. This region is home to some of the oldest stars in the galaxy, their light softened by age, blending into a warm golden glow. Though dense and bustling with stellar motion, the core feels peaceful when seen from afar, a quiet hearth at the center of a vast cosmic home. The stars here orbit in a variety of directions, creating a soft swirl rather than a tidy pattern. Their diverse paths hold traces of mergers, starbursts, and long-ago interactions that shape the galaxy's history. Each orbit is like a thread in the tapestry of Andromeda's evolution, and hidden within this tapestry lie clues that Andromeda once absorbed another galaxy's heart. Fact 57. Traces of a past. Galactic merger. Astronomers have discovered subtle evidence suggesting that Andromeda's core may contain the remnants of an ancient galaxy once pulled into its center. This evidence appears as a double nucleus, two bright peaks of starlight very close together, orbiting around the central black hole like a pair of glowing companions. One cluster may be the remains of a smaller galaxy whose core survived Andromeda's gentle but powerful pull. Over time, the two clusters blended into the luminous center we see today, their stars now intertwined and moving in complex orbits. Though the merger happened billions of years ago, the signature remains, like a faint fingerprint left behind in the light of the core. And from these ancient whispers, the galaxy continues carrying the long memory of every star and system that became part of its calm, spiraling form. Fact 58. The long memory of the core. The central region of Andromeda holds a quiet memory of every age the galaxy has lived through. Its stars move in layered patterns, some circling swiftly near the black hole, others drifting more slowly in wide, gentle arcs. These motions preserve the history of mergers, starbursts, and ancient tides, all written in orbits instead of words. Each star carries a piece of the past, shining faintly with elements forged by generations long gone. Over billions of years, the core has absorbed clusters, clouds, and even the hearts of smaller galaxies, blending them into its soft, glowing center. It is a place where the galaxy's deepest timeline is stored, not in static relics, but in the living flow of starlight. And near this core, stars in the tightest orbits move with astonishing precision, revealing even more about the heart of Andromeda. Fact 59. Stars in tight orbits. Close to the central black hole, stars move along extremely tight, graceful orbits. Paths so compact that they circle the invisible center in mere decades, far faster than stars farther out. These stars are like cosmic dancers tracing quick, elegant loops around a partner they can never quite see. Their motion is smooth and fast, guided by the intense gravitational pull at the heart of the galaxy. Because they orbit so close, these stars provide some of the clearest evidence of the black hole's mass. By measuring the speed and shape of their paths, astronomers can infer the nature of the dark object influencing them. Yet to these stars, the dance feels calm and consistent, unfolding without rush on a stage lit by the soft glow of surrounding starlight. And just beyond this whirling cluster lies the shadowed center of Andromeda itself, a place defined by what cannot be seen. Fact 60. The shadowed center of Andromeda. At the very heart of Andromeda is a region where light thins into silence, the shadowed domain surrounding its supermassive black hole. This area isn't completely dark. Faint glimmers of nearby stars and warm gas shimmer at the edges. But the center itself is a gentle void, a place where gravity gathers everything but offers no light in return. Despite its darkness, the region is calm, not chaotic. Material drifts inward softly, forming thin spirals of glowing gas before slipping beyond the boundary where light can no longer escape. This quiet balance between brightness and shadow gives Andromeda's core its serene, contemplative character. And as we drift outward from this silent heart, our gaze turns once more toward the connection between Andromeda and our own Milky Way. Fact 61. Our sister across the void. Andromeda is often called our cosmic sister, a neighboring spiral galaxy that mirrors our Milky Way in both shape and gentle grandeur. From Earth, it appears as a faint, misty patch of light, but in truth, it is an immense island of stars, drifting peacefully just beyond our galactic doorstep. Across the silent gulf between us, Andromeda shines with familiar patterns, sweeping arms, a glowing core, and a halo filled with ancient suns. This kinship reminds us that galaxies, like families, share quiet similarities, even across unimaginable distances. Andromeda's presence offers comfort, a reminder that our Milky Way is not alone in the vast dark, and every night, its soft glow reaches us with light that began traveling long before our world even formed. Fact 62. A galaxy we can see with the naked eye. On a clear, dark night, far from the glow of city lights, the Andromeda Galaxy becomes visible to the unaided eye. A gentle, elongated smudge hanging just above the horizon. It is the most distant object we can see without any help, shining faintly from more than 2 million light years away. To look at it is to glimpse across time, to witness ancient starlight that left its home long before human history began. This soft patch of luminosity has been noticed by skywatchers for thousands of years, long before telescopes revealed its true nature. Even as a blur, it inspires wonder, a reminder that the universe is filled with distant worlds, drifting quietly through the night. And the light we see is only the beginning. Its journey through space holds a story all its own. Fact 63. The long journey of light to reach us. Every photon of Andromeda's light travels an extraordinary distance before it reaches Earth, crossing more than 2 million light years of almost perfect darkness. Along the way, it passes drifting atoms, faint dust grains, and the thin outskirts of other galaxies. Yet it rarely slows, gliding steadily toward our skies. By the time it brushes against our eyes or telescopes, it has carried a message from ages long past. The stars we see now are not as they appear. They have moved, evolved, and changed while their light journeyed across the void. What we witness is a portrait frozen in time, a quiet memory of Andromeda's distant past. And as that ancient glow reaches us, the pull between our galaxies continues its slow, inevitable draw. Fact 64. The gravitational bridge between us. Although 2 million light years separate the Milky Way and Andromeda, a subtle gravitational bridge connects us across the void. This bridge isn't made of solid matter, but of quiet mutual attraction. A gentle, persistent pull that has been shaping both galaxies for billions of years. Even now, as Andromeda drifts through space, it is slowly inching closer, guided along an invisible thread woven by gravity itself. This connection creates faint streams of hydrogen and delicate motions in the outer halos of both galaxies. Though nearly imperceptible, these shifts reveal that our two cosmic homes are already intertwined in a long, slow embrace. And as this gravitational pull continues, the distance between our galaxies shrinks bit by bit, setting the stage for a future meeting. Fact 65. The slow drift that brings us together. Right now, Andromeda is moving toward the Milky Way at about 110 kilometers per second. Swift by human standards, yet astonishingly gentle on a cosmic scale. At this pace, the galaxies will not meet for another 4 billion years. The drift is so slow that even over many lifetimes, their positions in the sky change only slightly, like two faraway lanterns approaching each other across a quiet field. This motion is the result of gravity's patient tug, drawing both galaxies along their ancient paths. Instead of a sudden collision, the approach is calm and gradual, unfolding across unimaginable spans of time. For now, Andromeda remains a peaceful presence in our night sky, drifting imperceptibly closer. And when the halos of our two galaxies finally touch, a new chapter in cosmic evolution will begin. Fact 66. A future embrace, billions of years away. Billions of years from now, the Milky Way and Andromeda will meet in a gentle but transformative merger. Their halos will touch first, blending in soft waves of stars and gas that swirl together like two slow-moving clouds. Over time, their spiral arms will intertwine, stretching and reshaping into new forms as the galaxies pass through each other again and again. Despite the scale of the event, the vast distances between individual stars mean that few, if any, will collide. Instead, the galaxies will gradually settle into a new shape, likely a large, calm, elliptical galaxy that carries the heritage of both systems. This cosmic embrace is not an ending, but a continuation, a new harmony born from two ancient spirals. And before that distant future arrives, their halos are already beginning the first quiet touches of that long-awaited meeting. Fact 67. The first touch of colliding. Halos. Long before the Milky Way and Andromeda fully merge, their halos, vast ghostly spheres of ancient stars and dark matter, will gently brush against each other. This moment will happen far earlier than the visible collision, as the halos extend much farther than the bright disks we see through telescopes. Their meeting will be soft and quiet, like two distant clouds drifting into one another. In this early interaction, stars in the outskirts of both galaxies may feel slight nudges, shifting their paths by the faintest amounts. Streams of gas will begin to mingle, creating delicate bridges of material that whisper of the greater merger to come. Yet from within either galaxy, life would unfold unchanged, unaware of the slow transformation beginning in the dark. And as these halos blend, long tidal tails will someday stretch outward, marking the next stage of their cosmic dance. Fact 68. Tidal tails to be born someday. When the Milky Way and Andromeda eventually pass through one another, gravity will stretch their stars into long, graceful shapes known as tidal tails. These vast arcs will sweep across space like luminous ribbons, curving outward in elegant loops that trace the galaxy's first close passages. Though enormous in scale, these structures will form gently, unfolding over millions of years. Stars drawn into these tails will not collide or ignite. Instead, they will drift into long, diffuse streams that shimmer softly against the dark. Some may eventually fall back toward the forming galaxy, while others will wander the outskirts for eons, silent reminders of the delicate pull between two ancient spirals. And at the heart of this slow dance, a new galaxy will gradually take shape as the two settle into a shared center. Fact 69. A new elliptical galaxy to come. After several slow passes and long stretches of gravitational blending, the Milky Way and Andromeda will finally merge into a single, larger galaxy. Likely an enormous elliptical system, glowing with the combined light of both spirals. This new galaxy will have a rounder, smoother shape, lacking the distinct arms of its predecessors. Instead, stars will drift in broad, gentle orbits, filling the central region with a warm, diffuse radiance. Though transformed, this future galaxy will carry the history of both parents in its stars, clusters, and streams. Old suns from Andromeda will mingle with those from the Milky Way, sharing orbits for the first time. Over time, the system will stabilize into a serene, harmonious whole, a quiet testament to the calm power of cosmic evolution. And as we contemplate this distant future, the vastness of cosmic timescales brings a deep sense of peace. Fact 70. The calmness of cosmic timescales. In the universe, change moves with extraordinary patience. The approach of Andromeda, the shifting of stars, the slow blending of galaxies, all unfold on timescales measured not in centuries, but in billions of years. These spans are so vast that even dramatic events become soft and unhurried when viewed across cosmic time. What seems chaotic up close becomes gentle and inevitable from afar. This perspective reminds us that the universe is in no hurry. Galaxies drift, stars age, nebulae bloom and fade, all according to rhythms far beyond our own. Andromeda's journey toward us, though immense, is simply part of this quiet, ongoing flow. And as scientists study these immense motions, they trace the history of our neighbor back to the moment humanity first noticed its faint glow. Fact 71. Ancient eyes that first noticed the blur. Long before telescopes revealed Andromeda as a galaxy, ancient skywatchers saw it as a faint, mysterious blur in the night sky. In some cultures, it was described as a small cloud. In others, as a patch of soft light drifting among the constellations. Without knowing its true nature, early observers still felt its quiet presence, sensing that it was something distant and serene. For thousands of years, people looked up at this glowing smudge, unaware that they were seeing a neighboring galaxy filled with 1 trillion stars. They simply accepted its gentle brightness as part of the night, a soft companion to the stars. And centuries later, one astronomer would uncover the secret behind that blur, changing our understanding of the universe forever. Fact 72. Edwin Hubble and the distance to Andromeda. In the 1920s, astronomer Edwin Hubble studied variable stars within the Andromeda Nebula, measuring their gentle pulsing light. By comparing their observed brightness to their intrinsic glow, he discovered something astonishing. Andromeda was far too distant to be part of the Milky Way. Its light had traveled millions of years, meaning it was an entire galaxy unto itself. This realization expanded the boundaries of the universe overnight. What had once seemed like the whole cosmos, our own galaxy, became just one of countless islands of stars. Hubble's work transformed Andromeda from a faint blur into a gateway to a much larger universe. And from this discovery, new tools emerged to study Andromeda with ever greater clarity and calm precision. Fact 73. Variable stars as quiet messengers. The stars Edwin Hubble used to measure Andromeda's distance were a special kind called Cepheid variables, gentle, rhythmic beacons whose light brightens and dims in steady cycles. These pulses act like cosmic metronomes, allowing astronomers to estimate their true brightness, and from that, their distance. In this way, the stars become quiet messengers, carrying information across the vastness of space. Within Andromeda, Cepheids flicker softly, their light patterns whispering the galaxy's depth, size, and structure. They help map the spiral arms, trace the flow of stellar populations, and reveal how the galaxy has changed over time. Though faint from our vantage point, their steady rhythms continue to guide our understanding. And beyond these starry messengers, our modern telescopes reveal Andromeda with breathtaking, gentle detail. Fact 74. Modern telescopes. Revealing soft detail. With today's powerful telescopes, astronomers can observe Andromeda in exquisite detail, far beyond what early observers could have imagined. Instruments aboard the Hubble Space Telescope and large ground-based observatories capture its delicate dust lanes, glowing nebulae, and countless stars with clarity that feels almost intimate. In these images, the galaxy's soft textures come to life. Swirling arms, feathered halos, and shimmering star clusters. Different wavelengths reveal different layers. Infrared light uncovers warm dust. Ultraviolet highlights young stars, and radio waves map the calm flow of hydrogen. Each view offers a new perspective, like gently lifting the veils of the galaxy one by one. And with the rise of citizen science, even ordinary observers have found their own quiet way to explore this galaxy next door. Fact 75: the Andromeda Project and citizen science. In recent years, thousands of volunteers around the world have helped classify stars, clusters, and structures within Andromeda through a project known as the Andromeda Project. Using real astronomical images, participants marked clusters, dust lanes, and faint features, each careful observation contributing to a richer understanding of the galaxy. It became a calm, global collaboration, allowing anyone with curiosity to help map a distant world. This effort brought people together through shared wonder, transforming countless quiet moments at computer screens into discoveries woven into scientific research. Through patient attention and gentle observation, the public helped trace the galaxy's structure with remarkable precision. And as these collaborative efforts continue, deeper layers of Andromeda reveal themselves through wavelengths invisible to the human eye. Fact 76: infrared views of dust and glow. When astronomers look at Andromeda in infrared light, the galaxy reveals a warmer, quieter portrait of itself. Instead of the bright blue stars that dominate visible images, infrared shows the gentle heat of dust grains and older, cooler stars. The spiral arms appear smoother and softer, outlined not by brilliant clusters, but by long, glowing bands of interstellar warmth. Through these wavelengths, hidden structures emerge. Subtle rings of dust, faint ripples in the disk, and tiny patches of star formation tucked behind dark clouds. It is as though Andromeda breathes out a gentle thermal glow, one invisible to our eyes, but beautifully clear in infrared. And as we shift our gaze from warm light to more energetic wavelengths, another layer of Andromeda's ancient past becomes visible. Fact 77: X-ray light from old stars. In X-ray wavelengths, Andromeda reveals a very different and much older population of stars. These high-energy signals come from compact objects, white dwarfs, neutron stars, and quiet black holes, remnants of long-lived suns that have passed through their brightest days. Scattered across the galaxy, they form a faint, ghostly web of activity, visible only through sensitive detectors. Many of these X-ray sources exist in binary systems, where one star slowly draws material from a companion. As the gas spirals inward, it heats to extraordinary temperatures, releasing brief, flickering bursts of X-ray light. Though invisible to the human eye, these flashes are gentle hints of the complex, ongoing processes that shape Andromeda's stellar population. And beyond these energetic remnants, the galaxy whispers its structure through even gentler signals carried by radio waves. Fact 78: radio waves, whispering hydrogen maps. When astronomers tune their instruments to radio wavelengths, Andromeda speaks in quiet, extended whispers. These signals come from cold hydrogen gas, the most abundant element in the galaxy, drifting in vast sheets and filaments through the spiral arms. Radio telescopes trace this gas with remarkable detail, revealing patterns of flow and rotation that help map the galaxy's overall shape. In radio images, Andromeda appears softer and more diffuse, less defined by bright stars and more by gentle, sweeping currents of gas. These maps show where hydrogen gathers, where it thins, and where it waits to collapse into new generations of stars. It is the galaxy's calm background breath, the soft undercurrent that supports all future creation. And from these delicate signals, astronomers also measure how the galaxy moves and turns across cosmic time. Fact 79. Measuring Andromeda's rotation. To understand how Andromeda moves, astronomers study the subtle shifts in its light, tiny changes in wavelength that reveal whether regions of the galaxy are drifting toward us or away. By mapping these shifts across its disk, they can trace how fast different parts of Andromeda rotate. The inner regions spin more swiftly, while the outer parts move with a calmer, steadier pace, creating a smooth, graceful rotation curve. This rotation is one of the first clues that Andromeda, like many galaxies, contains far more mass than we can see. The stars move too quickly for visible matter alone to hold them in place, suggesting the presence of a vast halo of dark matter. Through these gentle measurements, the galaxy's invisible framework becomes quietly apparent. And from these studies, deeper mysteries about Andromeda's past begin to emerge like soft shadows at the edge of sight. Fact 80. The new ways we study a neighbor. As technology grows, astronomers continue discovering new and elegant methods to study Andromeda. Instruments that detect gravitational influences, trace chemical fingerprints, and capture light across the electromagnetic spectrum allow us to build a fuller portrait of our neighbor. Even small telescopes, aided by modern imaging techniques, can reveal star clusters and fine dust lanes that once remained hidden. Simulations also deepen our understanding. By recreating Andromeda's motion, interactions, and evolution on powerful computers, scientists explore how the galaxy formed and how it will one day merge with the Milky Way. These digital models flow like cosmic dreams, showing the galaxy's history in slow, unfolding steps. And beyond these tools lie the unanswered questions, mysteries that linger softly in the galaxy's starlit depths. Fact 81. The puzzle of Andromeda's past. Mergers. Andromeda carries subtle scars of past galactic mergers, faint rings, tilted disks, and uneven clusters that hint at long-ago encounters. These signs are delicate, sometimes barely perceptible, yet they speak of ancient galaxies that drifted too close and were slowly absorbed. Unlike violent collisions, these mergers unfolded gently across billions of years, each one adding stars, gas, and motion to Andromeda's growing form. The puzzle lies in interpreting these clues. Some features suggest a major merger in Andromeda's distant past, while others hint at a series of smaller, quieter interactions. Each trace is like a whisper from a forgotten era, preserved in the motions and compositions of the stars. And from these lingering signatures emerges one of Andromeda's most intriguing mysteries: the presence of not one, but two glowing hearts within its core. Fact 82. A galaxy with two nuclei. Deep in Andromeda's glowing center lies one of its most delicate mysteries. It appears to have not one, but two bright nuclei. These two luminous knots sit incredibly close together, separated by only a few light years, orbiting the central black hole like twin lanterns in the dark. One is slightly brighter and more compact, while the other is stretched gently into an elongated shape, giving the core an unusual diamond-like glow. This double nucleus may be the remnant of an ancient galaxy whose heart survived a slow merger and settled into orbit around Andromeda's black hole. Over billions of years, the two clusters have danced around one another, their starlight blending into a warm, flickering core. And this strange pairing hints at the complex tapestry of stars that make up Andromeda's inner regions. Fact 83. The mystery of its stellar populations. Andromeda contains a surprisingly rich mixture of stellar populations, each carrying its own quiet history. Some stars near the center are incredibly old, forged in the earliest days of the universe. Others are relatively young, formed from gas, drawn inward by ancient interactions. These groups overlap across the bulge, halo, and spiral arms, creating a mosaic of ages, colors, and motions. What makes this mixture mysterious is how unevenly it is spread. Some regions contain unexpected blends of old and young stars, while others host groups whose chemical fingerprints suggest origins far from the galaxy itself. These differences tell of merged dwarfs, absorbed clusters, and shifting waves of star formation. But the full story remains softly concealed, and surrounding these varied stars is a halo far more massive than once believed, deepening the galaxy's quiet secrets. Fact 84. The halo that seems too massive. Studies of Andromeda suggest its halo, the vast sphere of ancient stars and dark matter enveloping the galaxy, is surprisingly large and heavy. Its mass appears to exceed what earlier models predicted, stretching much farther into space and containing more material than expected. This expanded halo influences the motion of Andromeda's satellites and the rotation of its outer disk, guiding the galaxy with a soft but powerful gravitational embrace. What makes the halo too massive is not its size alone, but how smoothly it extends, hinting at a complex history of mergers and dark matter accumulation. The faint stars scattered throughout it serve as quiet markers of long-lost galaxies whose remnants now drift through Andromeda's outskirts. And beyond this immense halo lies another puzzle, a strange, uneven arrangement of satellite galaxies that circles Andromeda in a surprising pattern. Fact 85. The strange distribution of satellite galaxies. Around Andromeda, many of its small satellite galaxies aren't scattered randomly, but seem to align in a thin, gentle plane, as though arranged along an invisible sheet stretching through the halo. This unexpected pattern puzzled astronomers, who long assumed that satellites should orbit in more scattered, spherical distributions. Instead, Andromeda's companions appear to follow shared, coordinated paths, drifting together like birds gliding in formation. Some of these satellites even seem to move in the same direction, hinting that they may share a common origin or were shaped by the same ancient tidal event. Whether this arrangement is a cosmic coincidence or the remnant of a long-ago merger remains a soft, lingering question. And tied to this mystery is the motion of Andromeda itself, a motion faster and more complex than once believed. Fact 86. How fast Andromeda is really moving. For many years, astronomers measured Andromeda's motion by observing its approach along our line of sight, revealing that it is moving toward the Milky Way at about 110 kilometers per second. But this was only part of the story. More recent measurements have begun to trace its sideways motion, the tiny, nearly imperceptible drift across the sky. This sideways movement is so subtle that detecting it requires incredibly precise observations gathered over decades. By combining these motions, astronomers can estimate Andromeda's true path through space. The galaxy is not heading straight toward us, but approaching in a gentle arc, influenced by the mass of the Milky Way and the quiet pull of dark matter surrounding both systems. This fuller picture refines our understanding of when and how the galaxies will eventually meet. And as we follow Andromeda's path, we uncover signs of ancient encounters that once shaped its destiny. Fact 87. Traces of giant clashes. Long gone. Hidden in the broad sweep of Andromeda's structure are subtle signs of ancient collisions, immense events that played out over billions of years. These clues appear as faint ripples in the disk, oddly angled streams in the halo, and displaced clouds of gas that hint at past disturbances. Though the galaxy now appears calm and orderly, it carries the gentle scars of long ago encounters with sizable companions. One such clue is a large, faint ring of stars in the outer disk, believed to be the remnant of a galaxy that once plunged through Andromeda's plane. Over time, the disturbance spread outward, leaving a soft, circular echo that still lingers today. These features are difficult to see, but they offer quiet insights into the galaxy's ancient story. And beyond these memories lie questions about what dark matter may still be hiding in the unseen layers of Andromeda. Fact 88. The question of hidden dark matter. Though astronomers have mapped much of Andromeda's dark matter halo, great mysteries still linger in its unseen depths. Dark matter doesn't shine or reflect light. Its presence is known only through the soft tug it exerts on stars and gas. In Andromeda, this invisible mass seems even more abundant than expected, shaping the galaxy's rotation and anchoring its farthest streams of stars. Yet the exact distribution of this hidden substance remains uncertain. Some regions show signs of subtle clumps, places where dark matter appears denser, hinting at ancient mergers or lingering substructures. Other areas seem smoother, flowing like an unseen ocean around the galaxy. These patterns raise quiet questions about how Andromeda formed, how it grew, and how many stories are still stored in its invisible framework. And beyond the dark matter lies something even more delicate. Stars so faint and distant they barely whisper their presence. Fact 89. The unseen stars of the outermost reaches far beyond Andromeda's bright arms, where the galaxy fades into the quiet of intergalactic space. Countless faint stars drift in fragile orbits. These outermost stars are so dim and widely spaced that many remained undiscovered until recent decades. They lie in the galaxy's extended halo, moving slowly through regions where starlight grows thin and the night becomes deep and nearly empty. These stars are ancient wanderers, remnants of long-lost systems dissolved by Andromeda's gentle gravity. Some belong to faint dwarf galaxies now stretched into nearly invisible streams. Others were cast outward during past mergers, left drifting at the very edges of Andromeda's reach. Their presence reveals a halo far larger and quieter than once imagined, a soft boundary that blends into the greater darkness. And within this vast silence lies one final secret. Some mysteries of Andromeda may remain forever beyond our reach. Fact 90. Secrets that may stay forever quiet. Even with powerful telescopes and advanced models, parts of Andromeda's story may remain hidden in the soft shadows of cosmic time. Some stars are too faint for us to detect, their light lost before it reaches Earth. Some ancient interactions are too subtle, their traces smoothed away by billions of years. And some structures lie behind thick veils of dust that no wavelength can fully penetrate. These lingering mysteries are not frustrations, but gentle reminders of the universe's depth. They invite curiosity without demanding answers, offering a sense of wonder that complements the knowledge we do hold. Andromeda remains both familiar and unknowable, a neighbor we can study, admire, and dream about, even as parts of it stay quietly concealed. And from these mysteries, we turn towards softer reflections, the thoughts and feelings this galaxy inspires within us. Fact 91. What it means to see a neighboring galaxy. When we look up and glimpse the faint glow of Andromeda, we're doing something quietly profound. We're seeing another entire galaxy with our unaided eyes. In that soft blur lies a trillion stars, countless worlds, ancient clusters, and mysteries older than Earth itself. Yet it appears so gentle, so subtle, that it feels almost like a whisper from the universe next door. This sight reminds us that we're part of a broader cosmic family, connected not just by gravity, but by shared origins in the early universe. To see Andromeda is to glimpse beyond the boundaries of our own home, to recognize how vast and beautifully interconnected the cosmos truly is. And in that realization, we gain insight into our own Milky Way, a galaxy shaped by many of the same quiet forces. Fact 92. A bridge to understanding. Our own home. Studying Andromeda is a bit like looking into a softly lit mirror. Its structure, the spiral arms, the glowing bulge, the drifting halo, echoes the design of our own Milky Way, allowing us to learn about our home through comparison. By observing how Andromeda rotates, forms stars, and interacts with satellites, astronomers gain insight into the history and future of our own galaxy. Because we cannot easily see the Milky Way from the outside, Andromeda offers a precious perspective. It reveals what a galaxy like ours looks like as a whole, how its components flow together, and how it evolves across cosmic time. Every detail we learn about Andromeda becomes a clue about our place in the universe. And from these reflections comes a deeper appreciation for the patience and balance that shape all galaxies. Fact 93. A reminder of the universe's patience. Andromeda teaches us about the slow grace of cosmic time. Every star, every stream, every drifting cloud is part of a process that unfolds over millions or billions of years. There are no sudden leaps, no hurried changes, only steady motion, guided by gravity, shaped by gentle interactions, and smoothed by the passage of ages. This patience is a quiet comfort. It shows us that the universe evolves at a pace far beyond human worry or rush. The merging of galaxies, the birth of stars, the fading of light, all happen in their own time, without urgency. Andromeda embodies this calm, reminding us to breathe, to slow down, and to appreciate the long arc of existence. And as we reflect on this timeless stillness, we begin to see the galaxy not just as an object, but as a story written in starlight. Fact 94. A story written in starlight. Every region of Andromeda tells a chapter of its long cosmic story, not in words, but in the quiet arrangement of its stars. Young clusters glow with brilliant blue, marking places where the galaxy has recently breathed new life. Older, amber-colored stars in the halo whisper of ancient times when the galaxy was still forming, gathering companions and drifting through untouched darkness. The dust lanes, the sweeping arms, the calm central bulge. Each feature is a sentence written in light, shaped by gravity, time, and gentle motion. By reading this luminous tapestry, astronomers piece together Andromeda's history, tracing the events that shaped its present form. And as we decode these patterns, we learn that galaxies, like stories, are built layer by layer. And from this starlit tale, we also discover how the universe softens our sense of distance and imagination. Fact 95. How distance softens the imagination. Because Andromeda lies so far away, our view of it becomes naturally softened, like a distant landscape blurred by mist. We cannot see individual planets or small details, only the broad glow, the sweeping arms, the gentle gradients of light that define its shape. This distance invites imagination, encouraging us to picture the unseeable, the quiet worlds orbiting distant suns, the drifting clouds waiting to ignite, the ancient clusters hidden in the halo. The vast gulf between us and Andromeda acts like a filter, transforming something enormous and complex into a simple, calming blur. That softness gives the galaxy a dreamlike quality, allowing our minds to wander without being overwhelmed by detail. And from this softened view arises a feeling of kinship, a gentle recognition that Andromeda is both distant and familiar. Fact 96. A galaxy, both familiar and foreign. There is something comforting about Andromeda's shape. Its spiral arms mirror our own Milky Way structure, suggesting a cosmic kinship across the void. When we look at it, we see a reflection of home, a galaxy full of stars being born, aging, drifting, and glowing in quiet rhythms. Yet Andromeda also remains distinctly foreign, shaped by its own ancient mergers, its own waves of star formation, and its own orbiting companions. This blend of familiarity and mystery gives Andromeda its unique charm. It feels like a neighboring country in the great universe, close enough to understand, yet far enough to inspire wonder. Its light reaches us gently, carrying echoes of beauty that transcend the emptiness between galaxies. And from this duality rises a deeper comfort, a reminder of the shared origins that link all galaxies among the stars. Fact 97. The comfort of shared cosmic origins. Like every galaxy in the universe, Andromeda was born from the same ancient ingredients that shaped our Milky Way. The quiet hydrogen of the early cosmos, drifting through darkness after the Big Bang. This shared origin means that, despite the vast distance between us, both galaxies grew from the same cosmic threads. Their stars trace similar chemical stories, forged in the same early furnaces that once lit the universe's first dawn. This connection brings a quiet sense of unity. Andromeda is not a stranger, but a relative shaped by the same laws, the same matter, and the same ancient events that shaped our own home. When we observe it, we're looking at a sibling crafted from the same universal cloth. And within this kinship lies a gentle appreciation for the harmonious motions that guide galaxies through time. Fact 98. The quiet beauty of galactic motion. When we observe Andromeda's slow rotation, the drifting of its arms, and the calm paths of its stars, we witness a kind of cosmic ballet, a dance choreographed by gravity and carried out across billions of years. Nothing moves abruptly. Even the fastest stars follow smooth curves, guided by forces too subtle to feel, but strong enough to shape entire galaxies. From afar, this motion appears serene, almost meditative. The spiral arms sweep outward like soft brushstrokes, each one guiding clusters along wide, gentle orbits. Over time, the galaxy knits itself together with motion, forming a quiet harmony that can only be seen by watching across ages. And in contemplating this balance, we come to understand how Andromeda shapes our own sense of place in the universe. Fact 99. How Andromeda changes our place in the universe. Before Andromeda was understood to be another galaxy, humanity believed the Milky Way contained all the stars in existence. But once its vast distance was measured, our sense of the cosmos expanded in a single breath. Suddenly, the universe was no longer a single island of light, but a sea filled with countless spiraling worlds, Andromeda among them, drifting quietly nearby. This realization changed everything. It showed us that our galaxy is just one of many, that our home is part of a much grander structure. Andromeda became a familiar landmark in this new, expanded universe, a soft beacon reminding us that we live in a cosmos far richer and more interconnected than we once imagined. And from this shift in perspective, we approach the final reflection, a gentle, dreamy tribute to Andromeda itself. Fact 100. Andromeda as a gentle guide for dreamers. Andromeda has long been a quiet companion in our night sky, a soft, hazy glow reminding us of how vast and peaceful the universe can be. For countless generations, it has offered a sense of calm wonder, inviting dreamers to look upward and imagine distant stars, drifting clouds, and worlds hidden in the dark. Its slow approach toward the Milky Way tells a story of patience, of gentle motion unfolding across ages far beyond our own. In its spiraling light, we find comfort, a reminder that even enormous cosmic structures move with grace, following rhythms older than any life on Earth. Andromeda invites us to soften our breath, slow our thoughts, and see ourselves as part of something beautifully expansive. And as we drift into rest, its distant glow feels like a quiet promise that wonder will always be waiting in the sky. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. Drifting through the soft light of the Andromeda Galaxy, we've explored 100 sleepy wonders, each one a quiet reminder of the vast, peaceful universe surrounding us. If you enjoyed wandering through these dreamy facts, don't forget to like the video, subscribe, and share in the comments what topic you'd love to fall asleep to next. Your suggestions help guide future voyages for all the sleepy travelers who join us here. And when you're ready to keep dreaming, tap the end screen to watch the next sleepy astronaut video and continue your quiet voyage through the cosmos. Sweet dreams, and see you among the stars.